Welcome. So now we're going to look at making a function continuous. So f of x equals x squared minus 1 for x less than 3. And 2ax for x greater than or equal to 3. So we need to find a so that f of x is continuous. To make sure that our piecewise function here is continuous, we have to make sure that both halves of the function are, we have to make sure that the two halves of the function meet up, right? Because individually, both halves of the function are continuous. We have a quadratic, we know quadratics are continuous, and we just have a linear function, and linear functions are continuous. Right? The problem is at 3. That's the only place where our function, our piecewise function here, could have a break in it. Right? If the two pieces at 3 don't equal the same value, right, then we're going to have a jump discontinuity. Right? So the concern is making the limit of f of x as x approaches 3 from the left-hand limit, equal the limit as x approaches 3 from the right-hand limit. Right? So that means we need the limit of x squared minus 1, because that's the left-hand piece. Let me get rid of that box here. Right? Because it says for x less than 3. We have to make sure that's equal to the right-hand limit, the limit of 2ax, as x approaches 3 from the right, because that's the function for values greater than or equal to 3. Right? So for those two limits to be equal, the two halves of the function have to be equal. So we'll set those equal to one another. Now you might think, how am I going to solve this? It's got two variables. Except it really doesn't. It only has one variable because we know the value of x. Right? X is equal to 3. Right? It's the breaking point and the only place that our function could be discontinuous. Right? So the only candidate for a discontinuity. So that's the only thing we need to make sure of. Right, so we're going to find the value of a that makes our function continuous. All right, so we're going to plug in 3 everywhere we see an x. 3 squared minus 1 equals 2a times 3. Let's simplify that. All right, so that would be 9 minus 1. That's 8. And this is 6a. Divide both sides by 6. All right, and we should reduce that. I should have wrote it just a teeny bit smaller. I'm running out of space to write my answer. I'll just put it over here. A is equal to 4/3. Right? And, oops. Yes. Divided both by 2. 4/3. Right? And that's our answer for A. Right? So when A is 4/3, our function is continuous. And that's all there is to making a function continuous. Right? Thanks for watching this podcast. Right? In the next podcast, we're going to be looking at continuous functions. Bye for now.